Kia ora, Year 10, 11 and 12. In this video, I'm going to go through questions 6 and 7 from the May-June 2020 paper, and I should have said up there in the top because there were 3 papers for that exam session. It's paper 52. Okay, so there's a big Perms and Comms question here that is worth 9 marks. Always the hardest part of the Stats 1 paper, I think. And then the second question, question 7, is a pretty straightforward binomial and then geometric question. So I'll probably get to that, but most of the video is going to be spent going through how we do this Perms and Comms problem quite slowly. And for part B, there are at least two different ways to do that question. Okay, so let's just read through all 3 of them first. In the first one, we've got to find the number of different ways in which the 10 letters of the word summertime, all one word, can be arranged so that there's an E at the start and an E at the end. So if we think about that one straight away, we can see that we're going to have to deal with the fact that we've got 3 M's in there. But we'll come back to that a bit more carefully soon. Then we've got to figure out the number of different ways in which we can arrange the 10 letters of the word summertime so that we don't have 2 E's together, right? So there are 2 E's in the word. There's an E here and an E here. We don't want to have them together. This is the one where there are 2 different ways to do it. And then the last one, where we're going to look at cases, is where we're choosing 4 letters out of 10 from the word summertime, and we have to find the number of different selections if the 4 letters include at least 1 M and exactly 1 E. So as soon as we read that, we should be thinking about, well, do I care about the order of the letters or not? And I don't, right? So I'm just finding the number of different groups of 4 letters that I can have in there. So that tells me straight away that this one is going to be a combination, right? These ones are going to be what we call arrangements, where we're mainly working just with factorials. Okay, so starting off slowly with this first one, the way I always do these problems that you probably know by now is that I just draw some little lines, right? So the little lines we've got here is we've got to have an E at the start and an E at the end. So it's going to go like this, E and then 1, 2, 3, 4, 5, 6, 7, 8, and then an E at the end. Now, what letters have I got? Now, you might be watching this and thinking, man, she does this really slowly, but that's because if we screw this bit up, things don't really get any better from there. So we've got rid of the 2 E's, and we've got 3 M's, and they're all the same, right? We can't tell the difference between this M, and this M. It's not like they're different colours or anything like that. And then we've got S, U, R, T, I. So there are 8 ways to choose the first letter here, and then there are 7 ways to choose this one, and 6 to choose this one, and so on. So this is a classic arrangement problem, right? We've got the E's sitting here, and so there are 8 factorial ways to choose here. However, if I have an M here and an M here, if that's the first, so I think of them to start with as M1 and M2. There's no difference between M1 there and M2 there, and M2 here and M1 here, because the M's look the same. And that means that I've got double ups to account for. So that 8 factorial is too big. That's not the real number. The number of arrangements will be 8 factorial divided by 6, right, which is 3 factorial. And that basic method should be familiar from class, right? But if I've got double things that I need to undo, I'll just go through that really quickly, where that 3 factorial is coming from. We could have it as the first M, the second M, and the third M, or we could have the first, then the third, then the second. We could have M2, M1, M3, M2, M3, M1, and then the same thing for the 2 M3s, right? M1, M2, M2, M1. So that's where the 3 factorial is coming from, and they are all the same, so we don't want to double count. Okay, so when we chuck that into the calculator, what we get is we just end up with 6,720, because it's 8 times 7 times 6 times 5 times 4. I'm hoping that most of you found that problem reasonably easy. The next one is trickier, right? So we have to find the number of different ways in which the 10 letters of the word summertime can be arranged so that the 2 E's are not together. So I think the easiest way to think about this one is to say, well, how many ways are there to arrange those 10 letters, full stop? And then how many ways are there to arrange it so that the E's are together? And we're looking for the difference. And if you read the examiner's reports on AS stats papers over the years, one thing they say is that good candidates usually have a little bit of a story about what they're doing. So I'm just going to jot down some strategy notes. So number one is how many arrangements. Just call it how many R's. And then number two, how many with ease together. And then number three, which is what we want, is number one, take away number two. And that makes it much easier because both of those first two things are quite easy to do. So how many arrangements are there altogether? Well, we've got 10 letters, 6, 7, 8, 9, 10. So that means we've got 10 factorial ways to arrange the letters. But again, we have to get rid of the doubles. So we've got 3 M's, so divide out by 3 factorial, and we've got 2 E's, divide out by 2 factorial. That gives us a whopping 302,400 ways for that bit. Now, how many ways are there with the E's together? So this is step 2. So that's number 1. Right, number 2. Think of EE as one block letter, right? Imagine it's a Lego block and it's got EE on it now. That means that I've then got 9 more letters to arrange. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I've got my 3 M's and then I've got my SURTI. That means that all up here, there are going to be 9 factorial ways to arrange those 9 letters, right? Because EE is now being treated as 1. But I've still got the thing that I've got 3 M's and they're indistinguishable. So I'm going to divide out by the 3 factorial. Now, some of you might have gone, well, maybe I also should divide out by a 2 factorial. But we don't have to do that because we've got those sitting there together as a block, right? So we don't have that problem to deal with. So 9 factorial over 3 factorial gives me 60,480. So my answer, just going back to that strategy, sorry, the dog has woken up and is, I think, trying to get out of her crate. So there might be dog noises. Okay, so the answer is pretty simple, right? 302,400. Take away 60,480, which gives me 241,920 arrangements. Now, here's the second way. The second way is to actually answer the question directly instead of by using the complement. We've got 10 letters that we have to place, right? And we want the E's not to be together. So we've got 8 non-E's. So let's place those out in a line and think about how many ways to choose those. And then we're going to shove in the 2 E's. So the 8 non-E's are going to go like this. 1, 2, 3, 4, 5, 6, 7, 8. And we know how many ways there are to arrange those. So here we've got M, 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 S, U, R, T, I. So we've got 8 factorial, and we've got to get rid of the doubles. So it's 8 factorial times 3 factorial. Now, how many ways are there now to plonk in those 2 E's? Well, they have to go in 9 different places, right? So they can go anywhere, including the 2 N's. They can go anywhere in the 7 gaps between those 8 letters, or they can go at this end or this end. So there are 9 places to put the first E in, right? And that means that then there are 8 places to put the second E in. So I could have an E here, and I could have an E here, right? Or I could have, well, you get the idea, right? Hopefully you get the idea. But if I've placed an E here and an E here, that's the same as if I placed, if this is E1 and E2, we can't tell the difference between those 2 E's, right? So this is E2 and E1. So again, we have to divide out my doubles. So let's see if we're going to get the same answer, right? And we should get the same answer. So put that into your calculator or do it by hand. We get 8 times 7 times 6 times 5 times 4 times 9 times 4 from here. And that gives me, happily, the same number. So 241,920. I think both those methods are really nice and they come in useful in different situations. So just make sure that you've gone through how they both work. The AS Stats textbook has got quite a lot of questions on these, but the best way to get really good at Perms and Comms is just to do lots of past papers. Now, the fourth part here, part C, or the third part, is easy compared to that. We've got 4 letters to pick out of the 10 letters of summertime. Find the number of different selections if they must include at least one M and exactly one E. So when I get a question like this, I like to break it down into cases. And in this situation, I've got 3 cases. So let's just see what makes this easy. We're told that we have to have exactly one E and that we have to have at least one M. We've got 3 M's altogether. So case 1 is where I have one E and I have one M and then I have 2 more. Case 2 is where I have one E and I have 2 M's and then I have 1 more. And case 3, which is the easiest, is where I have one E and I have all 3 M's. And the 2 more are coming out of the non-E and M letters, which is S-U-R-T-I. Right, so how many ways? Let's start with the easiest, case 3. Well, we've got nothing left to choose, right? So there's only one way for this to happen. One way. Case 2, I've got one E and 2 M's, and then I've got to pick one more out of those 5. So it's just going to be choose one letter out of 5. And then here I'm choosing 2 letters out of 5, which is 5 choose 2. So 5 factorial over 3 factorial, 2 factorial, or just thinking intuitively, it's 5 ways to choose the first letter and 4 ways to choose the second letter. Sorry, but then I've got to take account of the fact that I don't care about the order, so I divide by 2. So that gives me 10, right? And that's where this combination things comes from. We don't care about the order, so we're dividing out our double ups. So altogether, that gives me 10 plus 5 plus 1, 16 ways. Right, now I'm up to 12 minutes already. I've got a grumpy dog, but I think I can probably just get through this little binomial problem if I go very, very quickly. So it's a binomial problem because we've got the probability that Moena messages her friend Pasha is 0.72, and we're doing this over 12 days. So N is 12, P is 0.72, and we need to find the probability that she messages Pasha on no more than 9 days. So X is less than or equal to 9. We're going to work at the other end. That's 1 minus the probability that X is 10, 11, or 12. So we need to show our working for the binomial, but this working should feel really, really easy by now. So it's going to be 1 minus, now I'll do the 12 first. There's just one way for that to happen, and it's got to be a success 12 times. So 0.72 to the power of 12. There are 12 ways for 11 out of 12 to happen. 0.72 to the power of 11 times 0.28. And then there are 12 choose 10 ways to get this next one. Okay, I've now got completely whingy dog in the background, so better get this finished. Right, chuck that in your calculator and you should get out 0.696, and that's to 3 significant figures. Then the next one is a geometric distribution, but I like to do these just using a tree. So it's a geometric distribution because we're saying how long does it take until she messages Pasha again. So using a tree, you can see this is only worth 1 mark, right? So here's your tree. What happens first? Well, we know she messaged her on 1st of January. So on the 2nd of January, she either messages or doesn't, right? So we want doesn't for the 3rd, doesn't for the 4th, and then on the 5th, we want her to send a message. So the doesn't probabilities are 0.28. So we're going to have 0.28 cubed. I bet no one's watching by now. If anyone's out there, come and claim your, I don't know, what's it going to be? It's not going to be chips from the canteen, maybe a fruit burst. Okay, so it's 0.28 cubed times 0.72. And when we work that out, we get 0.0158. Always remembering that we're going to 3 sig figs. So there you go. I've done work solutions for this paper, but I've picked those 2 questions first because the Perms and Comms question was the hardest one that I most want you working on. Email me if you've got any other questions that you'd like me to YouTube.